Hey math kids, today we're going to talk about tangents. So let's just start right off. We're given f of x is equal to this at the point 2, 3. What we need to do is take the derivative of this first, so f prime of x. We're going to think of this as x squared plus 5 quantity to the 1/2. So we bring down the 1/2, rewrite the inside, drop the exponent by 1, and then multiply by the derivative of the inside. Now we can simplify this if you want to by thinking of it as a fraction. So the top of the fraction is going to be 2x times 1, so just 2x. This 2 is on the bottom. This is going to be square root of x squared plus 5. So that's our gradient or slope function. We're given this point, which means that x equals 2, where we're interested in that. And so, actually these 2's can cancel. So that makes it a little bit easier. So we get 2 over square root of x squared plus 5, not that, this is a 2 as well. So 2 over square root of 4 plus 5, 2 over square root of 9, which means the slope is equal to 2/3. Okay, now if we use point slope form, which is y minus y1 equals m times x minus x1, we have the slope, we have a point, that's all we need. So y minus 3 equals this. And that is the equation of the tangent line. Okay. Okay, find the equations of any horizontal tangents to this. Okay, so we're going to, once again, find the derivative. So 3x squared minus 12 is going to be our dy dx derivative. Now, horizontal lines have a slope of 0, so we're going to set our slope function equal to 0, once again because it's asking for horizontal slopes, and we can just solve that. So x is equal to plus or minus 2, and so that means we're going to have two tangent lines that are horizontal, one at x equals 2 and one at x equals negative 2. And so those are the x values though, so we need to know the y values in order to find this. So if we take that and plug it in, we're going to get 2 cubed minus 12 times 2 plus 2. So that's 8 minus 24 plus 2. Those add together, 10 minus 24. So we get negative 14. So that's the equation of one of the tangent lines. Now if we plug in a negative 2, we get negative 8 plus 24 plus 2. Combine those, negative 8 plus 26. And then that's going to give us y equals 18, which is the equation of the other horizontal tangent line. Okay, so show that the equation of the tangent line y equals natural log of x at y equals negative 1 is y equals ex minus 2, so that is e times x, not e raised to the x. Okay, so when y equals negative 1, the natural log of x equals negative 1. So we're just plugging this into this. And then if we solve that for x, we would have to do e of both sides. And so x is equal to e to the negative 1, which is also 1 over e. So we know that the point where they contact each other, we get that. And if we take the derivative of this, we know that the derivative is 1 over x. And so all we need to do is plug in that x value to that. So to find the slope, we're going to do 1 over e, which if we do 1 divided by 1 over e, we do 1 times e over 1, which is just e. So the slope is equal to that. And if we plug that into y minus y1 equals m x minus x1, this is our x1, this is our y1, so y plus 1, or m, is just e, x minus 1 over e. We distribute, we get ex minus 1, because the e's would cancel on that, and y plus 1, we subtract 1, y is equal to ex minus 2, and that was what we were asked to prove. Okay, moving on. It says find the equation of the tangent using tan x and the point where x equals pi fourths. Okay, so y is equal to tangent pi fourths. If we just type that into a calculator, we will see that y is equal to 1. And so that means the point that we have is that. Okay, if we take the derivative of tangent, we get secant squared x. And if we plug in our x value, we're going to get secant squared of pi fourths. And remember, secant is 1 over cosine, so it's like saying 1 over cosine squared of pi fourths. Cosine of pi fourths, remember, is square root of 2 over 2. So square root of 2 over 2, quantity squared over 1, like that, or under 1. If we square that, we're going to get 2 over 4. So we're going to get 1/2. And so if we go through that 1 divided by 1/2, 1 times 2 over 1, that's just equal to 2. So the slope is 2. Y minus y1 equals m x minus x1. Plug in the point. Y minus 1, slope is 2x minus pi fourths. Okay, and that's it for that one.